are going to talk about solving quadratics by finding the square roots. So this is pretty much a review of what we talked about yesterday. So this is when we do not have the linear function or the linear term, the bx. So we want to get everything on one side, and so I'm going to go ahead and I'm going to bring this negative 16x squared over to the other side. So I'll go ahead and add 16x squared to both sides. And so we have 16x squared is equal to 500. We want to get x squared by itself, so we're going to divide by 16. And so then we'll take the square root of the top and we'll take the square root of the bottom if possible. And so then we'll have x squared is equal to 500 all over 16. And we want to see if we can reduce that a little bit further. And we can see what we can take out of each one. And so we'll reduce this down to 125 all over 4. And so then we're going to go ahead and take the square root of both of these. And so x is equal to, and that's going to be plus and minus because we're going to have a positive root and a negative root. And then we want to go ahead and break this down into, see if we can find the perfect square that goes into 125. And that's going to be 25, and so that can be broken down into the square root of 25 and the square root of 5 all over 4. And so this is going to be plus or minus 5 square roots of 5 all over 2. And so that's x is equal to that. We can also write that as a decimal, and so we can put 5 square roots of 5, divide that by 2, and get plus or minus. All right, so why don't you go try letter B and see what you come up with. When you finished, you should have x is equal to plus or minus 3. The most important part of this is that when you take the square root, you have to end up with 2 roots. So you're going to have a plus 3 and a minus 3. If you were to just go in and write a plus 3, that would be counted wrong because your answer is a positive 3 and you have a negative 3. So make sure that you're writing your plus and your minus at the same time. All right, so the next one says quadratic equations are used in many applications involving geometry. So on the star, they love questions that have to do with geometry. And so this is a cube. I know it does not look it, but all these sides should be the same. So the surface area of a cube is 150 square feet. We want to find the length of each side or each edge. And so this is known as our side. So our surface area is equal to 6 times s squared. That is our formula. And so we'll plug in what we know. So 150 is equal to 6 times s squared. We're going to divide by 6. And so s squared is equal to 150 all over 6. And then we want to see if we can reduce that down. And so we'll take the square root of both sides. And so s, when you take 150, is going to be plus or minus 5. Well, since we are talking about the length of a side, we can't have a negative dimension. So my answer in this case is only going to be 5 feet. So yes, one of the answers is a negative, but you can't have a negative dimension. So that's what we talked about the other day is our extraneous. And so I'm not going to write the negative because I'm only looking for the positive dimensions. On letter D, the surface area of a sphere is 80 square meters. We're looking for the radius. So a sphere, which you guys know me by now, I'm not a very good artist. And so this is a sphere, and this is a radius. So the surface area is going to be 4 pi r squared. So we're trying to find this radius. We know this is going to be 80. And so we're going to just go in and we can use 3.14, or you can just plug pi into your calculator. If you plug pi, then your answer might be a little bit different than mine. And so we're going to divide by 4 pi divide by 4 pi. And so here we're just going to go in and pick up our calculator. And yes, I know the last time I think I had the calculator, it was in a different language. And so now we'll just have 80. We're going to hit Control Divide, put 80, and then 4, and then pi down here. And then we're going to get 6.3662 is equal to r squared. And then ask yourself, how do you undo a square? By taking the square root. Control Divide. And then your answer is going to be r is equal to plus or minus 2.523. And since we're looking for a radius, our radius cannot be negative. So r is equal to 2.52, and that's going to be meters. So cannot have negatives. Hey Panthers, we're going to look at the falling object model. When an object with little air resistance is dropped, its speed continually increases. The height, which is h in feet of such an object, is given by the model. H is equal to negative 16 t squared plus HO, where HO is the starting height. So another name for the starting height is going to be the y-intercept. So this is the y-intercept, or the starting height. This is the initial height, and this is going to be your height that you're ending with. And t is the number of seconds it has fallen. So this is your y-intercept, the starting height, and this is the height in feet of the object. So an engineering student is in an egg dropping contest. The goal is to create a container for an egg so it can be dropped from a height of 32 feet. So this is your starting height without breaking the egg. So this is going to be your h sub 0, or h naught. So to the nearest tenth of a second, about how long will it take for the egg's container to hit the ground? So we're going to use this equation, h is equal to negative 16 t squared plus h of 0. So basically, we're looking at something that's just basically in the first quadrant, and we're starting up here, and we're going to drop it, and we're looking for this right here. And so we know that it's going to be facing downward. This is where we're starting, and this is our 32 right here. And we want to know how long is it going to take for it to hit the ground. And we're looking for this height right here, and this height when it hits the ground is going to be 0. So we'll plug that in. So we'll have 0 is equal to negative 16 t squared plus, and then your height when it starts is going to be 32. And so your graph will be something that looks like that. And we're looking for the time. And we want to get t by itself, so we can bring one of these over. And so we'll have 16t squared is equal to 32. Divide by 16. And then we'll have t squared is equal to 32 divided by 16, which is 2. And then we want to get the t by itself, so we're going to take the square root, and so the time is equal to the square root of 2. So we'll go ahead and put this into our calculator. And so the square root of 2 is equal to plus or minus 1.41, and so 1.412, and we're looking for, I believe that it said to the nearest tenth, and so that's going to be 1.4, and I can't have negative seconds, so my answer is my time is equal to 1.4 seconds, and we cannot have no negative time or no negative seconds, so my answer is 1.4 seconds. So why don't you go try letter F and see if you can do that without me. See if you can find your initial value, see what your height is when it hits the ground, and see if you can figure it out. All right, so hopefully you read the question. And so we know that 72 is our initial height, and so that's going to be a negative 6t squared, and that's going to be plus 72. It says about how long will it take to reach the surface? And so when it reaches the surface, our height is going to be 0, so we plug in a 0 there. We'll move the negative 6t squared over, so we'll have 6t squared is equal to 72, and go through all that steps so we can get t squared by itself. So 72 divided by 6 is going to be 12. I'm looking for my time, so I'm going to take the square root. So t is equal to, I'll put that in my calculator, and the square root of 12, and that is going to be 3.46. So plus or minus 3.46. And for this one, we'll probably round to the nearest tenth. We'll have to read the directions. And so time is equal to if we round to the nearest tenth, that would be 3.5 seconds. And we will not have negative time, so no negative time.